I'm Alex. I'm a DevOps coach and mentor at DLM Consultants, and I'm a Microsoft Data Platform MVP. I'm also one of the co-organisers of Data Relay, which in normal times is a conference that roves around the UK, and I'm the creator of SpeakingMentors.com. If you want to get into speaking at local tech meetups or bigger events, and you want somebody to help you, check out SpeakingMentors.com. I'm talking today about one of the biggest problems that I see with database development and deployment. It's the provisioning of dev databases, dev and test databases with the appropriate data that you need to test that your stuff works. It's one of the biggest problems I see, and I'm going to team up with one of my friends, Stad, who has created some of the software that we're going to use during today's presentation.
Hi, I'm Sander. I'm a SQL Server DBA living in the Netherlands. I work for Waypoint Analytical. I'm a major contributor to the DBA Tools project, and I'm the maintainer of the dbaclone repository. I'm a recently renewed Cloud and Data Center MVP, which means I do a lot of stuff with PowerShell and automation.
We're going to start off with a story. Josh spins his chair around to Maxine. Mrs. Chambers, I've got to show Randy something, but I just emailed you what we've got in terms of documentation for new developers. There are wiki pages where I've assembled all of the release notes we've written and the documentation from the development teams. There's also links to the stuff we know we need to write. Hopefully that will get you started. Maxine gives him a thumbs up. As they leave, she logs into her new laptop and is able to get in and open up email, miraculously working the first time. But before looking at what Josh sent, she pokes around to see what else is on her new laptop. Immediately, she's mystified. She finds links to HR systems and network shares, to company resources like expense reporting systems, payroll, time card systems. She finds Microsoft Word and Excel and the rest of the Office suite. She frowns. This is fine for someone in finance, but not a developer. There are no developer tools or code editors or source control managers installed. Opening up the terminal window, she confirms that there aren't any compilers, Docker, Git, nothing. Not even Visio or OmniGraffle. Holy cow, what do they actually expect new developers to do? Read emails and write memos? When you hire a plumber or a carpenter, you expect them to bring their own tools. But in a software organisation with more than one developer, the entire team uses common tools to be productive. Apparently here on the Phoenix project, the toolbox is empty. She opens her email to see what Josh sent. It takes her to an internal wiki page, a tool many engineers use to collaborate on documentation. She tries to scroll up and down but the document is so short, there isn't even a scroll bar. She stares at the nearly empty screen for several long moments. Screw you, Chris, she thinks. That was an extract from the Unicorn Project by Gene Kim, which is a sequel to the Phoenix Project. It's a novel about an IT project that goes completely wrong and how they fix it. The Unicorn Project differs from the Phoenix Project in that it follows a developer on the front lines rather than a senior operations leader. So you hear the same story from two different perspectives, one from the dev perspective, one from the operations perspective. And one of the things that the Unicorn Project goes into in a lot of detail is the pain that developers have just trying to get work done. Systems, the way that we work doesn't tend to be designed for the ease as a developer, and that causes a huge amount of inefficiency in the system, and it's just a painful way of working that isn't productive. One of the things that they draw on a lot at the beginning is the pain that Maxime, our hero, has when she's trying to build a development environment. And that's one of the things that I see a lot of the time with databases. As a result, what I see a lot is folks using shared development databases, which is all sorts of evil and is the root cause of so many problems that we see in database development teams. There will be people, I'm sure, watching this that use a shared database, and some of them might even advocate for it, but I'm here to tell you it is wrong, it is evil, you should never ever do it. And a few reasons why it's bad. First of all, you have no isolation of work. If you and I and somebody else are all working on the same database, I make some changes, you make some changes, I can't test that my changes in isolation work or don't work. I often miss dependencies between something I'm doing and something you're doing. It also means that if I break something, I've broken it for everyone. I've once worked in an environment where somebody accidentally deleted all the users on the development database and 100 people couldn't log on and do any work. And it took them about a week to fix it because the DBAs were worrying about a production issue and they didn't have time to come down and deal with less important dev issues, as far as they were concerned. We also have the issue of overwritten work. It's quite common when two developers are working on the same piece of code. If they're working on the shared development database, they can overwrite each other's work. People say they shouldn't do it because we should have better project management, but it happens, and it's a pain. And these breaking changes do hurt everyone. But one of the biggest issues is what happens next. It's when we try and deploy. When we try and deploy our changes, we're saying, okay, so what do we need to deploy? And then you look at the diff between the development environment and the production environment, and there's a whole list of changes because you've made changes, I've made changes, half a dozen other people have made changes, and you have to go through and cherry pick, I want this and I want that, and you always forget something, or there's always something a bit complicated because both of you have made a change to the same stored procedure and they want your bit but not my bit, and it's horrible. It turns all of the deployments into this custom, manual, risky process. When I deploy something, I want to deploy the entire thing, not just part of it, which is why branches are so good, but we'll get onto that. We also end up with inconsistencies along our pipeline because inevitably old code or half-developed code or code that never really worked out ends up being left on the development database. We end up with stored procedures and tables be called so-and-so underscore to delete or underscore my name or underscore your name or underscore dev. And it just becomes a mess. You don't know what's important and what's not important. You don't know what it's safe to delete and what it isn't safe to delete. And this causes all sorts of delays and overhead, and it also ends up with it works on my machine issues, where you hadn't realized that you've got some dependency on some test code that isn't actually running in production. This leads to overhead for operations and DBAs, having to manage these shared databases, because inevitably a shared database ends up becoming the responsibility of the DBAs to look after. And so whenever you want any changes or you need a new environment, you need to send a ticket to the DBA team, and then the DBAs get distracted from their very important work to build you a development database, and it's not working for everybody. As a final thought about why shared databases are evil, imagine that you're a .NET developer. I don't know how many of you have got experience working in .NET, or maybe you're a C# developer or a Java developer, or you're working on something else. You're an application developer of some sort. Imagine if I told you, you know what we're going to do? We're going to put all of the files on a file share and we're all going to hack away at them at once. You'll be breaking the build all over the place. No one would stand for that, yet that's what we do for databases. So we need to move away from shared databases as a matter of urgency. However, whenever we do that, we run into three immediate problems. The first is the sharing of changes. Figuring out how to, when you've got 12 different people all working on their copy of the database, figuring out what's the correct version, what's my version, what changes are coming from where. Managing all those changes is hard. But the application folks have figured out how to solve that a long time ago with source control systems. We just need to adopt them properly. The next problem is the size of the data. When I'm working on a shared dev environment, it's possible to spec it out quite well and to put a whole bunch of data on there. When I'm working on my own local workstation, probably a laptop, probably a dev computer, it very possibly does not have the space to hold terabytes worth of data. And even if you could, we then run into the next problem, which is data privacy, data sensitivity. We all know that we need to think very carefully about what data is exposed to which people, and we want to avoid sensitive data being copied across everywhere to every single developer workstation. That would be a bad idea. That's what data breaches are made of. So, in this talk, we're going to try and solve each of these problems, and we're going to start with the sharing of code, and that's using source control tools like Git and GitHub. So what is GitHub? GitHub is a website that is owned by Microsoft that allows you to host Git repositories. What is a Git repository? Well, a Git repository is basically a collection of files that you want to keep under source control, your code, and it keeps track of your entire history. And what you can do is you can check out that code, you can make some changes, and then you can check in your new changes. However, because we're using Git, we're into the new generation of source control tools. It's not a simple check out, check in. It's a distributed source control system. So what that means is the main repo lives on the server. That's my remote repo. And what I do is I clone the entire repo, history and all, onto my local machine. And then I've got an entire copy of the repository on my machine. I can then make changes in what's called the working copy. As far as I'm concerned, it's just files on disk that I'm messing around with. And when I'm ready to commit, I can commit those changes. And after I've made however many commits I want, when I'm ready to share my changes with the rest of my team, I can push those changes back up to the server. It is a bit of a leap from old school centralized source control systems like SVN or CVS or TFS. But it is a significant step forward for a few different reasons. First of all, it allows you to work in a disconnected fashion. And when, let's imagine a crazy scenario where some massive world emergency goes on and we all have to start working from home, being able to work very, very close to my local repository and commit solves a whole bunch of networking issues that you often see with old traditional centralized source control systems. And it also means that my latency is next to nothing, which is great. It also means I can do a whole bunch of private work, make a bunch of private commits while I'm still testing stuff out, while I'm still figuring stuff out in my head, while I'm still trying out various ideas before I share them back with my team. And if I screw something up, then I can just blast away my local repository and clone it all over again. And I've not impacted anybody else by my screw-ups. It's a much safer place to work, which frees me up to try things out and experiment and to learn, which is great. Another fun advantage is that basically, because everybody's cloned the entire repo to their local systems, effectively, if the worst happens and your server goes down, if the website, GitHub, goes down, you've got a whole bunch of other copies on local dev workstations. So you do kind of have an unofficial additional recovery strategy available to you there. And finally, branching. Distributed version control systems are amazing at branching. And a lot of people get hang-ups about branching from the old centralized version control days. And the reason they do it is because with the old school source control tools, branching was painful and hard. With Git, it's easy. It's almost too easy because you can get yourself into problems, which is why I recommend trying to be a little bit strict about how you do it. And one of the outcomes of these two wonderful books, Accelerate and the DevOps Handbook, is based on analysis of trends within IT organizations. Those organizations that practice trunk-based development tend to do very well. What this basically means is you have one branch which is always deployable, and it is very, very, very close to what's in production. You could, in theory, deploy it at the click of a button whenever you wanted to, and the world would not catch fire. It might be extended with release branches, you might extend it with feature branches for short-lived pieces of work, but we're not going to spend weeks and weeks and weeks working on a feature branch and try and merge it back, because that's going to be very painful. So Git and GitHub allow us to keep track of code changes, scripts, where it allows us to see the changes in them over time, and allows us to understand who's doing what and when, and to share that and to make sure we've always got the latest version and we can deploy the right version. But databases aren't just a bunch of scripts. They're typically MDF and LDF files, right? So MDF and LDF files don't easily go into source control because source control is designed for small files, just a schema, not the data inside the database, and human readable files typically. So we need some way of scripting out that database that can be used to reliably rebuild that database from scripts. And that's where DACFX and SSDT and Microsoft Visual Studio comes in. SQL Server Data Tools comes with Visual Studio, and it allows you to script out all of the schema objects in your database as create statements, and it can then use schema comparison technology to compare the state of the code versus the state of a target database, and it can generate a script and it can deploy that code for you. That's really cool. It's worth mentioning that there are various other different tools that do this sort of stuff, and some of them are model-based or state-based. That means they define your source code is defined as the state that you want to create. And there are also migration-based tools where you basically save an ordered list of migration scripts, and that includes tools like dbup and flyaway and Redgate SQL change automation. Both tools have a place, both tools are valuable, they do work very differently, it's worth calling that out. If you want to learn more about that, I do have a session that's all about the difference between the model-based and the migration-based way of source controlling stuff, so do check that out if you're interested. But today we're going to be using SQL Server data tools, and I'm going to hand over to Sander now, who is going to give you a demo of how to create a Visual Studio database project, a couple of really handy, nifty ways to do it quickly to get started with, and then how you can use that code to build a database.
So the first thing we're going to do is put our databases in source control, which means we are going to create an SSDT solution which will contain all our objects and our tests and everything. But creating these SSDT solutions is a manual task in Visual Studio. And there's no easy way to automate that normally, but I found a way to do that. So let me demonstrate that. So when I first had to do this, I had to do this for 35 databases, and then opening Visual Studio, and go to File, New Solution, give it a name, put in the projects, import all the objects, put in T-SQL-T libraries, all these kind of things. Became pretty tedious very fast. And I hate to do repetitive tasks, so I automated this. I created the SSDT with T-SQL-T template. And this template is a complete representation of an SSDT solution which I created through the PS module development PowerShell module. And this is developed by Friedrich Weinmann, and this is part of the PS framework PowerShell module. And this enables you to not just do this with files, but complete directories. So the only command that we have to run, this entire script will take care of a couple things, like downloading the latest template, installing it, and extracting it. But the only command that we need specifically is invoke psmd template. And we give it a template name, we set the output path, and then we give it a name. And the name is, in this case, is the database. And if we run that, create SSDT project, it's going to download it, extract it, and done. And now we have our solution. You couldn't do this manually in the same time. So let's open that. Let's go into Visual Studio and see how it looks like. This takes a couple seconds because Visual Studio has to initialize the project. Almost done. There we are, preparing it. And let's take a look at how it's all structured. So we have two projects, one for the data model and one for the tests. And the reason I did that is because I want to separate these two. I only want to have tests in my test project, and I only want to have the data model in that other project. And this data model is referenced in the tests project, so you don't have to import any objects twice or whatever. So if we want to do an import, we just go to right-click the data and the project, do import, click on database, select our database, and in this case I'm just going to say object type for the folder structure and say start. And this takes a couple seconds. It does import the thing. This cannot be automated, unfortunately. But you only have to do this once. So now we have our objects all in here, but we don't have any tests. And when I started doing unit testing with databases, I found that some tests were really important, like the existence of objects, table columns, index columns, collation of my database. These are all important tests and pretty basic tests. So I created a PowerShell module called the PSTG test generator. And what this does is it looks at your database and all the objects and downloads the objects and looks into them and creates these basic unit tests for you. And if you have a small database, this may not be of any benefit, but still it's going to be fast. But if you have a large database, like more than 100 or 1,000 objects, you can generate over 4,000 or 5,000 unit tests in a couple of minutes. So let me demonstrate how that works. So I'm going to say 01 create SSDT project, SSDT unit tests. And what this does is, like I said, it takes a snapshot of your database. So it collects all the objects. There we go. Create unit tests. Collecting the objects. There we go. So you see the first tests already there. Test if table command dbo.comments exists. Really important. If you accidentally drop a table in your project, then this could be disastrous if you do this if you deploy that into production. So it does the same thing with the correct columns, for the indexes. And when that's done, we're going to import these tests into our solution. So I'm going to right-click test, basic, do add, and then existing item. Let me check if that's correct. Yeah, that's done. So select all my tests. Done. Now I have a complete solution with both my data model and my basic unit tests. And of course, you need other kinds of unit tests in there, really going into the store procedures and test if the functionality works. But these are the basic unit tests. And if you want to know more about these basic unit tests, I have another session at SQL Bits that will where we'll go into the specifics and why you should do all these kind of things. So now we can do a build. And we can do builds using the msbuild.exe. So this little script is going to build my project. And I'm going to use the tests project. So I have all the tests in there. And I'm going to use the publish dba deck package PowerShell command, which is available in DBA tools. And this is a really easy way to publish the deck packs you get generated. So let's run that. Let's clear the screen a bit. Build. By the way, all the demos you'll see today are available on my GitHub page. Go to the presentations, find this session, and you will have all the demos. The demos are free. You can change them, download them, reteach them, whatever you want to do with them. They're yours. So they're yours to use. Do whatever you want. So we had no build errors. There we go. And it's done. Now we can go to our server and say, okay, let's say Stack Overflow 2013 tests, and let's run tsqlt.run all. which is the command that we can use to run all the unit tests. And there we are. So we generated about 38 tests. And when we run all the unit tests, we had 38 succeeded of 38 test cases. Of course, this is going to be successful because it took the current state of the database. So you don't do this every time for that same database. So you only do this initially. But we have our unit tests, we have our complete project, and now we can do builds and deployments. Back to you, Alex.
And now, children, we're going to read Oh, the Places You Go by Dr. Seuss. You can get so confused that you start into race down long wiggled roads at a breaknecking pace and grind on for miles across weirdish wild space, headed, I fear, toward a most useless place, the waiting place. For people just waiting. Waiting for the train to go, or a bus to come, or a plane to go, or the mail to come, or the rain to go, or the phone to ring, or the snow to snow, or waiting around for a yes or no, or waiting for their hair to grow. Everyone is just waiting. Or waiting for the fish to bite, or waiting for the wind to fly a kite, or waiting around for Friday night, or waiting, perhaps, for their Uncle Jake, or a pot to boil, or a better break, or a string of pearls, or a pair of pants, or a wig of curls, or another chance. Everyone is just waiting. No, that's not for you. Somehow you'll escape all that waiting and staying. You'll find bright places where boom bands are playing. That was an extract from Oh, the Places You'll Go by Dr. Seuss. I regularly sit in that chair and read that book to my son, which is why it holds a special place in my heart. But Gene Kim also uses it as an example of a poorly performing IT organisation, where every single time you want to get something done, you have to ask 15 other people to do something for you. And this causes huge delays. In actual fact, when I was reading the Unicorn Project for the first time, sat in that exact chair, I had the book, Oh, the Places You'll Go, next to me, because I'd been reading it to my son the night before. So that was a personal little coincidence that I thought I'd share. Why is this so inefficient? Well, if we go back to The Goal by Eliyahu Goldratt, it's a similar book to the Phoenix Project, but it's based in a manufacturing setting, and it's all about Toyota manufacturing system style principles, talking about value streams, lean, constraints. And if we imagine the processes that it takes to produce my product, kind of raw materials coming in at one end and finished products coming out the other end, in an IT setting, we're thinking about backlog charts and things on one side, and we're thinking about finished software on the other end. And there are various different things that have to be done along the way. Each time a piece of work is waiting for a delay, it's time wasted. The amount of time that people spend doing work might actually not be very high, but the amount of time it takes to release something into production is enormous. This is why it often takes weeks or months to get a piece of work into production when actually it only took a few hours of development time. What Eliyahu Goldratt says is that there's always one constraint, or one primary constraint, and any improvement that is not made at that constraint is a waste of time. Because anything that happens in the process before that constraint just piles up work before the constraint, because there's only so much work that can get through this constrained operation. And any improvements we make afterwards are going to have negligible effect, because actually everything is bottlenecked by this single constraint. And Gene Kim elaborates on this in IT. This is a direct quote from Beyond the Phoenix Project, which is an audio book that follows up on some of the principles in the Phoenix Project book. He says, what I find so amazing is that as an organization goes from code deployment lead times that are measured in months, maybe even quarters, down to minutes, the constraint moves in some pretty predictable ways. And this is the order: environment creation, code deployment, testing, architecture, innovation. And if you've ever thought of, if you ever think about what DevOps means to you, a lot of the time it means basically that list of things, because they're the most common constraints that are blocking us from picking up a piece of work off the backlog, doing the work and putting it into production and seeing whether or not it worked. Environment creation is normally the first one. That's why infrastructure as code tools, Puppet, Chef, whatever, they were so big in the kind of DevOps space. If you think of a DevOps tool, a lot of the time it's one of these kind of spin me up some infrastructure, often in the cloud at the click of a button type thing. So let's think about development databases. I don't want to wait for a DBA to spin me up a dev server. I don't want to share my dev environment with everybody else. But I do want to make sure it's installed consistently. I want to make sure that any developer can do it, and when they do it, it's quick, because I don't want to wait for hours for it to install. And I want to make sure that I don't have to use any, that nobody else is required. I don't want to have to open a ticket and wait for somebody else to do this for me. I want to be able to do it myself. I want self-service. I want speed. I want fewer dependencies on other silos, and I want consistency. Consistency is really important as well. I don't want everybody to install SQL Server themselves by clicking through the UI for it. I want to make sure that when everybody installs it, they do it in the same way. I have been in organizations in the past where different people have installed SQL Server, but they've had different default collations, and that's caused issues in source control and deployment time. So what's a really cool tool for me to allow me to do this? And Docker is a fantastic tool for solving that problem. I'm not going to go into a huge amount of detail on how Docker works because we don't have enough time, but I'm going to give you the headline principles. Why is it so amazing? You can think of a Docker container a little bit like a virtual machine. The difference is the Docker container does not include the operating system. In any virtual machine, typically the application that you're working on is relatively small, but so much of the footprint of that virtual machine is the operating system itself. When you're running a bunch of VMs on your dev box, you're running several copies of the entire operating system over and over again, and that's really, really expensive. It takes up a huge amount of your resources, it takes up a bunch of space. There's only so many of those you can run at once. With containers, all we're doing is carving out a little bit of space on the host machine where you're running your applications and binaries and things, but they're reusing the host operating system. This means they're far faster to spin up. They take up far less space on disk. You can run far more of them at once. They're far more lightweight, and they're ideal in a development context for, right, I've got this new piece of work, spin myself up a new container. That takes a couple of seconds. I can do my work. I can check it works in isolation on my machine, and if it does work, I can blast away my container. I don't need it anymore. I can check my code into source control, probably the other way around, and get on with my day. So if you'd like to learn more about Docker, check out Andrew Prusky's deep dive session. I should also say a massive thank you to Andrew Prusky. This slide is completely lifted from a presentation that I did with Andrew last year that included Docker as well. So thank you, Andrew. I really appreciate it, and do go and check out Andrew's session tomorrow morning. Before you can start using Docker, you need to enable a couple of features. In Windows, you need to make sure you've got the Windows Pro Edition or you're using the Server Edition. But once you've done that, you can start using Docker, and that's what Sander is about to do now. So Sander, over to you. Knock him out with this demo.
This was our previous script. We did a deployment to our local instance using DBA deck package, publish DBA deck package. But now we want to use Docker. And this is almost the same script as the build. The only difference is that I have a Linux VM running Docker. If you have Windows 10 Professional with Docker installed, you can just point to your Docker instance instead. So we set a couple of credentials. We set the instance with the port and the name of the database. And the rest of this script is still going to be the same as the previous one. We're still going to use the deckpack path, the same profile path, and we're going to use the publish dba deck package command. So let's run that script and build to Docker. So here we are. We already built our deck pack, which only took like 2 seconds. We've restarted our container. And this is my identifier. And now it's going to publish the deck pack. This can take a couple seconds. Like we know, the instance still has to start up in the background, and the deck pack publish script is going to look for any changes and apply these using the state-based migrations. There we are. Found all the objects, and now we have deployed our database. So let's look at that. Do a refresh, and now we have our database in my SQL Server container, and we have our tables, and we have our stored procedures, everything in there. So this is how we can do deployments to a SQL Server instance running as a container. Back to you, Alex.
Now we're going to catch up with Maxime on the Phoenix project. Maxime opens up a terminal window on her laptop and starts following the instructions Kurt gave her. Her excitement grows when she realises this might be an actual working dev environment. She's exuberant when she's able to log in and type make on a command line, which starts streaming screenfuls of happy output onto her screen. She's delighted as she sees files getting compiled, binaries getting linked, programs being copied, build tools being installed and run. The output keeps going and going and going. Amazingly, things are still building for 10 minutes, 15 minutes, 30 minutes. She's relieved as it keeps going without an error, but starts to become alarmed at the size of the Phoenix build. It's huge. Like most developers, she's very superstitious that if she stops watching the build, it will fail. Finally, nearly 3 hours after she started the build, she sees the scrolling output on her build window stop. Her heart falls. She reads, build error, missing file, credentials.yaml. Damn! She's guessing she needs a logon credential that she doesn't have. She texts Kurt and he quickly replies, ah yes, for that you need to open a ticket to get your login tied to your Active Directory account. Only Susan can issue those. Contact info coming. The waiting place. That was another extract from the Unicorn project. Maxime has managed to gather around most of the things that she needs, but building her dev environment still takes way too long, and she only finds out at the end that she's missing a very crucial piece. Now let's talk about databases. We've so far been able to use source control and SSDT projects, Visual Studio database projects, to be able to keep track of our database code. And we've been able to use containers to spin up instances to deploy our databases to. That's great. But one of the things that a lot of us need when we're developing databases is data. Now, exactly the sort of data that we need varies from person to person. And if you ask different people, they will tell you different things. For example, they need realistic data. They don't need dummy data, they want realistic data about real people. They want a large amount of data so that they can test it performs well. Otherwise, you only find out about performance issues when you try and run it on production. We want to be able to find those issues much earlier in the process. If the developers don't get feedback on what works and what doesn't work, it's no wonder they're going to start putting cursors into production and the DBAs are going to get upset. We need to be able to give developers the ability to do that in their dev environment. Immediately, though, we run into a couple of problems. One, the data is massive a lot of the time. It's not going to fit on a developer's machine, and copying it around takes forever. If I was Maxime trying to build my development database, it might take me hours to copy, or longer to copy across all the data, and I probably don't even have space on my machine anyway. The next problem is compliance, data privacy. That's really, really important, and we're not going to cover it in a huge amount of detail in this process. You absolutely should add some sort of masking process to your provisioning process. And what I recommend you do is go to Chris Unwin's session tomorrow morning. He's going to talk about how we can manage the security of that data, and it's really great. What we're going to focus on now is the size of the data. How do we move a lot of data around that has been appropriately masked quickly and easily, so like Maxime, we don't end up waiting for 3 hours only to find out that it's failed. Over to you, Sander.
Let's talk about dbaclone. When we want to create test environments for our databases, we always struggle with the size of our data. If you have a couple small databases, and small in my opinion is less than 100 gigabytes, then putting these databases on test environments is not that big a deal. But if you're talking about 1, 2, or maybe 10 terabytes of data, then this really becomes a problem because storage may be cheap, but putting all that data on the test system is both costly and risky. So what if we had a solution that we could clone our databases and really downsize the size of our databases and put those on test systems? That's where dbaclone comes in. So how does this work? dbaclone creates a so-called image where it takes a backup of your current database and restores it in a virtual hard disk file, a VHD file. And when it's done, it closes that file, and from that moment, it's an image. It's a file which we can create clones from. And when we create that clone, it only becomes around 350 megabytes. So listen closely. If you have a 4 terabyte database, your clone will only be 350 megabytes in size initially. Be careful though. Any changes that you make in the clone database is going to represent on that system. So if you have a very large database and you are going to re-index all your indexes in your entire database, and all those changes are going to be saved, that's going to generate a lot of data. So be careful with that. So it's only the delta that gets saved in the clone. That's why the initial file is going to be so small. So we've seen me demo how we can create an SSDT project, put in all the objects in the tests, then use it to deploy it to Docker. But now we want to go a step further and use the data from the current Stack Overflow database. But the Stack Overflow database is pretty large. It's about 60 gigabytes in size. And if I have to do that every time, it's going to be costly. So let me demonstrate how that looks like. So when we go and look at our script with dbaclone, we have the same kind of setup as we had in the previous scripts. We still have our build, but now beforehand we are going to create a clone. And from there, we're going to restart our SQL Server container. I'm going to use the same credentials, but instead I am going to create the database using the create database and point to a couple files because I created a share between my Docker container and my current host. And then I'm going to execute that query, and this will attach my database. Then I'm going to run the same deployment with the publish DBA deck package like I did before. First, let me remove the current image. So I'm going to say database, Stack Overflow. Yes, I want to be sure that I have the current one. Okay, that's done. And now I'm going to run the 03 build Docker and dbaclone. Let's run that. So we have our build. There we are. Now we have our clone. We are restarting our SQL Server container, and now it's going to deploy that deck pack to the SQL Server container. Because previously we didn't have any rows, because our project didn't have any rows in it, because there's no scripting and that inserts any rows. We didn't have any data. Now we have. So again, this takes a couple seconds to initialize. There we are. Now we've deployed our database. Let's go to refresh our database right here. And let's look at how much data is in the tables. And we have data. So now we have a 60 gigabyte image changed to 350 megabytes. And I'm going to show you where that is. So I'm going to open Explorer. And I'm going to go to my dbaclone, clone, and here is my database. You can see that this file is pretty big. That's the maximum size of a clone that you, or an image that you can use. It's 64 terabytes. So as long as your database is less than that, you can create an image for that. But my initial one is less than 400 megabytes, and we are a little above the 350 because we did the deployment. But my image is 51 gigabytes in size. So, and you can do multiple clones on a single instance from the same image. So this is really powerful if you want to do stuff with changes and see if you create another index to see what that change is gonna hold. So back to you, Alex.
Thank you, Sander. So what have we learned today? Shared databases are evil. We want to be working with local development databases that I can spin up quickly and easily. One of the really nice things about what we've done today is effectively spun up an environment that's exactly like production. And then the first thing we've done is we've deployed our source code to it in exactly the same way that I would do on production. What this means is that every single time somebody starts a new piece of development work, they are testing that the latest version of the source code can be successfully deployed to production. You can bet that a whole bunch of deployment problems will be caught much earlier, and it's going to save you from making those problems on production. What's more, the tech to do this is available today, and it's broadly free. Okay, so you've got Docker, you've got there's a paid version of that. You've got dbaclone, which is open source. You've got SSDT, which get the appropriate MSDN subscription, and most of you have probably already got it anyway. And you've got the dev version of SQL Server. So all of this stuff is available right now for free. You can start using it. You can set up your own proof of concept right now for free. What you should also do that we haven't covered in this session is make sure that you're handling your sensitive data effectively. We've shown you how you can take all your production databases and spew them into development domains, but if you're not making sure that you've stripped out all of that sensitive data, then that's the sort of stuff that data breaches are made of. So please, please, please do take data privacy seriously. There are various other tools. We used Git and Docker and dbaclone. There are various other tools that are available. So aside from Git, I do recommend that you use Git as your source control system, but you can host it in various different places. We chose GitHub for our demos today, but you can host your Git repos in various other places. As for database tooling, we used SSDT, DACFX, and the Visual Studio Database projects. So that's the set of tooling we use today. There are a whole bunch of other tools that are available. They're all great, and they're all pretty well established nowadays. So your mileage may vary. Try out various different ones. As for containers and clones, dbaclone is similar to what you get with Redgate SQL Clone. What you get with Redgate SQL Clone on top is you get, if you buy the provision version of that license, you get a whole bunch of data masking stuff built in. You also get a nice web UI that you can use for managing stuff, and it's a bit easier. You don't have to be a PowerShell expert to be able to use it. Windocs is kind of a replacement for dbaclone and also Docker containers all built into one, but they kind of, you're using Windocs instead of Docker, so you're betting against Docker if you're using Windocs, which is a pretty bold move to make. However, Windocs does have a few advantages. It supports Windows authentication, you've got clones built in, and they were kind of first to be able to port SQL Server into a container, so it's got that going for it. Actifo and Delphix, they do similar sort of stuff with clones. They are a lot more expensive. So if you have a lot of money to spend and you're willing to look for those sorts of features, then go for it. And when I say a lot more money, I'm talking like 10 times what Redgate costs. So I've put them there. If you would like to read any books, I've referenced a whole bunch of books. These are some of my favourites that have influenced me as I've been writing this presentation. There's a whole bunch of other good ones out there as well. Also, Sander had used a few other bits and pieces in this session. So Sander, would you like to talk about some of the Cody extensions that you used?
Is we use tsqlt to do all our unit testing with. We've used the PSTG test generator to generate all those basic unit tests. And we've used the SSDT with tsqlt template to create our SSDT solutions. And these little extensions help you to really speed up your development process. And I hope this helped you out a bit.
Thank you, Sander. I think that was really cool. I started out today saying that I had this really big problem with the way that we provision ourselves dev databases, and it's always really painful. And I hope that you found something in the session today which might be able to help make that a little bit easier for you, whether it's GitHub, whether it's Docker, whether it's dbaclone. Sander, I'm really excited about stuff that you're doing with dbaclone. If you want to contact me about any DevOps coaching, consulting, training, mentoring type stuff, here are all of my details on the screen. And Sander?
Yeah, if you want to contact me on anything you've seen today, like the test generator or unit testing in general, these are my details.
Thank you very much for having us.
Thank you.